Hello, and welcome back to Breadboard Robotics. Today, I'll revisit one of my first ever projects, the operating replica of the drone from the video game Rainbow Six Siege. My first attempt was bulky and used inefficient components. My goal with this new project is to shrink the overall size, weight, and integrate a Flysky controller to improve control. I also wanted to use an LED bar and an analog camera, just like in the game. This is my components list. You can see that I have a Flysky receiver and transmitter. I did a previous video on how to read the iBus from the receiver on a Raspberry Pico. I also have a RP2040 Zero, which is just a smaller packaged Raspberry Pico. I have two 12-volt geared brushed motors to drive the wheels, a DRV8833 motor driver, and also a Buck Convertor for stepping down the voltage to a safe 5 volts for the smaller components. We also have a 11.1 volt Lipo Battery, an 8 LED stick, XT30u Connectors, and an analog FPV camera and receiver. Now that we got the boring stuff out of the way, we are going to go ahead and jump into the build. I'm using a 3D printer to print the lower, upper, and wheel sections with PLA Filament. Now, since I was trying so hard to keep the overall size down, I realized it was pretty tricky to fit all of the components inside the cylinder. What I discovered for the Flysky receiver is that I could remove the plastic outer casing and use the smaller profile inner board to save space. So now we need to take our Buck Convertor and solder on a XT30u connector so that it can be powered by our battery pack. Just before you see me soldering, I'll be cutting out some heat shrink to apply it to the wire. I'm using my soldering station to tin each of the input wires and the connector. When it is time to join the pieces together, I will press them together and apply the iron until the solder melts. Once they are joined, I'll remove the iron for a few seconds and then release the components once the solder rehardens. The DRV8833 is going to need a 11-volt connection directly from the battery. So on the solder joints we just made, I'm going to add an additional positive and negative wire accordingly. I'll add a little bit of flux to the joints to overcome any issues with oxidation. The ends of these wires will be soldered directly to the DRV8833 board. Speaking of oxidation, you'll see me occasionally wiping my iron with steel wool and tinning the iron with solder. This is important in order to prevent the tip of the iron from oxidating. You need to do this regularly or risk ruining your tip. The final step for this section of wiring is going to be using my hot air rework station to shrink the heat shrink. This will protect the joints from shorts and wear. Here is a close-up of our work. The FPV camera I have runs really hot when it's powered. You can see me taking some measurements of the temperature around the camera, and it's returning 163 degrees Fahrenheit. It makes me nervous to put a component this hot in an area with minimal airflow, so I plan to attach an aluminum heatsink to increase the surface area. You can see that this actually works to some margin, but it is still hot. I'll just have to live with this for now. I also have the camera receiver, and you can see the video comes through with pretty much no latency. So now I have to solder a bunch of electrical components together. If you want to pause the video, I'll have the wiring schematic there. Otherwise, I'm going to go ahead and fast forward through. Okay, please don't blow up. Haha!
want to see part 2 of this project, don't forget to subscribe below.
Thank you for watching. If you enjoyed, please leave a like. And if you want to see uploads on future projects of mine, please hit the subscribe button.